This video is for exponents and scientific notation. So in the past few videos we've talked about the rules of exponents. Now we're going to kind of combine them all together. So we're going to have to determine which rule of exponents to use in order to simplify these problems. So in this example I want to do p to the 6th q to the 3rd divided by p to the 11th q. So notice we are dividing here. So I'm going to use my rule of exponents with division. So with division you have to have a similar base. Once the bases are similar, you subtract the exponents. So we start off looking for a base that is similar. So I notice I have a p in the top and a p in the bottom. Those are similar bases that I'm able to divide. And then I also know I have a q in the top and a q in the bottom. Those are similar bases that I will also divide. Alright, so remember when we are dividing here, all we're doing is we're subtracting the exponents to the similar bases. So the base of p, I have 6 minus 11. 6 minus 11 is negative 5. And the q, 3 minus, again there's technically a 1 there, is 2. So I have q squared. One major important thing to understand with exponents is you never want to leave a negative exponent. That's a big mathematical, I guess you could say, no-no, something you'd never want to leave. So we're going to get rid of that negative exponent by using that fourth rule of exponents. So if there's a negative exponent, all I'm going to do is reciprocate it, which means move it to either the numerator or denominator based upon where it is, and take away the negative exponent. So notice this p to the negative 5th is in the numerator, because again I could technically write anything over 1. So I'm just moving the p to the negative 5th. So in my numerator, q squared will stay because the q has a positive exponent. So q squared stays in the top. And then the negative exponent on just the p means that I reciprocate it. So since it's in the numerator now, it goes to the denominator. And when I move it to the denominator, I take away the negative exponent. So if I'm dividing p to the 6th q to the 3rd by p to the 11th q, I get a solution of q squared divided by p to the 5th. Let's look at one more example of all of these properties kind of combined together. So I have the quantity 20p to the negative 5th times p cubed all over p to the negative 2nd. So yes, you can get rid of negative exponents first. I like to simplify as much as I can before I get rid of negative exponents. So I'm going to simplify the top. I have the numerator, or the top of my fraction. I'm just multiplying two expressions here. So I'm going to multiply what I can. So I know in the numerator here I have a 20. I don't have any number in the second one, so I'm not able to multiply that. In the numerator I also have a p to the negative 5th, but then I also have a p cubed. So I'm able to multiply those because they have similar bases. So when I multiply these out here, in the numerator I have 20 p to the 5th p to the negative 5th times p cubed. Again, when I'm multiplying stuff with similar bases, all I'm doing is adding the exponents. So negative 5 plus 3 becomes a negative 2. And that stays as an exponent on the p. But remember, I'm dividing that by p to the negative 2nd. Notice now I have no more multiplication, but I do hopefully you've noticed here that I have a p in the top of the fraction and a p in the bottom of the fraction, and I'm just dividing them. So I'm going to use my quotient rule of exponents, where if I'm dividing stuff with a similar base, I subtract the exponents. So I'm going to write this out because I want to make sure we understand we're doing -2 minus -2. The minus and negative becomes a positive. So I have -2 plus 2, which becomes 0. So in my solution here, I have 20 p to the 0 power. Again, please don't forget all these rules of exponents. Any value raised to the 0 power becomes 1. And the only value that's raised to the 0 power here is p. So really, p to the 0 power becomes 1. So I have 20 times 1, which is just 20. So when I'm trying to simplify the original problem of the quantity 20p to the -5th times p to the cubed, all divided by p to the -2nd, I get just 20.